Okay, welcome to FM Shushon Academy. Okay, we're continuing with, we're looking at the topic electricity. Okay, and we'll be looking at resistance. Okay, so there is one resistance in series, also resistance in parallel. Okay, circuit. So there's the resistance in series circuit and also the resistance in parallel circuit. Okay, for example, if they give you, this is two cells, first cell and second cell there, maybe I put third cell there, and then it's like this, and then they give you first resistor there and then second resistor there. This thing goes up to there. Have you seen these? They are all in one line. These resistors, can you see them? They are all in one direction. Have you seen? They are all in one line like this. So such resistors, this is resistor 1 plus resistor 2, this is resistor 3. So these resistors are what you call, these resistors are in what? They are in series. Okay? The resistors, these resistors are in series because they are following one another in series, these resistors. So for example, in the exam, if they give you something like this, okay, and then they bring for you resistors like this, okay, and then they want you to find, let's say this one is 2 amps, okay, this one is 3 amps, 3 ohms, sorry, this one is 4 ohms, and then this one is 2 ohms. Okay, let me put this one as 1 ohm, and then they say calculate the total resistance. Okay, total resistance. So how do you calculate the total resistance? How you calculate the total resistance? You say RT, which means R total, and then you ask yourself, how many resistors do I have? I've got resistor 1 there, resistor 2 there, resistor 3 there, resistor 4. So when they're in series, the way they are, they're in one line, you just add them. So to be resistor 1 plus resistor 2 plus resistor 3 plus resistor 4. And what are the ohms? Resistor 1 is what ohm? Resistor 1 is what ohm? Resistor 1 is what ohm? 1 ohm, 1 ohm plus 3 ohm plus 4 ohm. You can see there, resistor 1 is 1 ohm plus 2 ohm plus 3 ohm, 1 plus 3 plus 4 there, resistor 4 there, as you can see, it's 2 ohms, so plus 2 ohms, and then you add them, so it will be 1 plus 2, 3, 3 plus 3 here, it makes 6, 6 plus 2, so 6 plus 2, it's yes, so 1 plus 2, 3, 3 plus 3, 6, 6 plus 2, 8, so it is 8 ohm, 8 ohm, 8 ohm, okay, 8 ohm, and then we go, that's how you calculate. So whenever they give you to calculate, so the answer is 8 ohm, so that's what you do. So do this exercise now. Actually, before I do the exercise, let me show you the resistance in parallel. You see, in series, you just add them. Resistor 1 plus resistor 2 plus resistor. So resistance in parallel. The one we are dealing with was resistance in series, okay? Now in parallel. In parallel, you have got resistors that are written for you like this. There's a resistor there. There's another resistor maybe here. And then they come like this. Okay? Of course, and then maybe here there's a battery. Okay? You see, these are parallel to one another. This resistor here, resistor 1, is parallel to resistor 2. They are not in the same straight line. One is on top, the other one is down. Okay? These resistors are called the resistors in parallel. So for example, if they say, they give you a situation whereby they put a resistor like this, and another one like this, and then they're like this, for example, and then there's a battery there, okay? And then this is the 2 ohms, okay? And then this one is 3 ohms. Have you seen these resistors are not in series? And then they say calculate the total resistance. So if they say calculate the total resistance there, whenever you are calculating the total resistance in parallel, you always put 1 over RT, which means total resistance. T means total resistance is equal to, you always put 1. You always put 1. For in parallel, you always put 1. And then you ask yourself, how many resistors do we have? There are 2 resistors. There's this one and there's this one. So that's the first resistor, resistor 1. Okay, resistor 1, and this one is resistor 2. So it will be 1 over resistor 1. 1 over RT is equal to 1 over resistor 1 plus 1 over resistor 2. If there are 3, you say again plus 1 over resistor 3. If there are 4, so you keep on adding, but there are only 2 resistors, so this is not necessary. So it will be 1 over RT. So 1 over resistor 1 is what? 2 ohms there. So you put 2 plus resistor 2 is 3. So we always put 1 there. 1 over RT, and then you substitute R1 and R2. So you continue. 1 over RT is equal to 1 over 2 plus 1 over 3. 1 over RT. You have done, this is grade 9 mathematics. This is a fraction. You know the common denominator for 2 and 3, it is 6. 2 into 6, 3. 3 times this one on top, times this one on top, it is 3, plus 3 into 6, it is 2. 2 times the 1 there, it's 2. So it will be 1 over RT is equal to 2 plus 3, 5 over 6. So it will be 1 over RT is equal to 5 over 6. When you reach here, you already know what to do. We have learned this in grade 9. For you to find RT, you're supposed to cross multiply. You remember how to do it. You're supposed to cross multiply. So 5 times RT, 5 RT is equal to 1 times 6. It will be 6. And then when you reach here, divide by 5. I think you remember this. Divide by 5. So RT is going to be equal to, what is 6 divided by 5? So when you divide 6 divided by 5, what answer are you going to obtain? You are going to get 1.2. 1.2 what? Ohms. You see, that's how you do it. Okay, that's the answer. So they can be more than, sometimes they can bring for you 3 of them. Okay, they can bring one like this, they bring another one like this, and then they go like this. They can even bring another resistor like this. There are 3. Okay, they can even bring 4. Okay, I'm just trying to make you understand something. Okay, maybe there's a battery here. Okay, and then this one is 2, this one is 3, let's say this one is 4. Okay, this is ohms there, this is ohms, this is ohms. And then they want you to calculate, this is example 2, calculate the effective or total resistance. Effective, it means total resistance. Effective resistance. Okay, we'll calculate the total resistance, the same thing. So how many resistors do we have here? There are 3 of them. So it means we have, this is resistor 1, resistor 2, resistor 3. They are in series, they are in parallel, not series. Have you seen one's on top, the other one is down, this one is down. They are following one another straight but down, not in a straight line. So we are going to have 1 over RT. How many is R1? How many resistors there? 3 plus R2 plus R3. If there are 4, you write R up to R4. If there are 5, up to R5. 1 over RT is equal to 1 over 2 plus 1 over 3 plus 1 over 4. Those are the ones that are here. 2 there, R1, 3, R2, 4, R3. And then you know how to do this. And then what do you have? So I've got 1 over RT is equal to 1 over 2 plus 1 over 3 plus 1 over 4. So 1 over RT in grade 9, you already know how to do this. The common denominator for 2, 3, and 4, it is 12. Okay, the lowest common denominator. And then 2 into 12, it goes 6. 6 times 1, it is 6 plus. 3 into 12, it's 4. 4 times 1 there, it's 4 plus. 4 into 12, it is 3. 4 into 12, it's 3. 3 times 1, 3. And then to be 1 over RT is equal to 6 plus 4, 10. 10 plus 3, 13. 13 over 12. And then you are finding RT. So 1 over RT is equal to 13 over 12. Then you cross multiply. Cross multiply. When you cross multiply, this RT times 13, it will be 13 RT is equal to 1 times 12, it is 12. You divide by 13 this side, divide by 13 this side. RT is going to be equal to what? What is 13 divided by 12, guys? So you say 13 divided by what? 13 divided by 12. It will give you 1 point something. You see, 1.083 ohms. That's how you do it. That's how you do it. So that's how you deal with the resistance in series and resistance in parallel. Now, sometimes they can give you an actual question. So they want you to there's also what they call how to work with Ohm's law. Okay? Ohm's law. Okay? And Ohm's law is this. Okay? Resistance is equal to voltage over current. And Ohm's law states that, Ohm's law, what does Ohm's law state? Ohm's law states that current is direct proportion to voltage. Okay, between the two ends of a conductor. You have learned this Ohm's law in grade 9. That's what it states. Current is direct proportion to voltage between the two ends of the conductor. Okay, so that formula is very important. You need to know how to use it. This formula, the one I've written here, this one, you already know that V, this V means voltage, I means current, R means resistance. Okay, V means voltage, that you know, which is measured by V. Okay, and then I means current, which is measured by it is abbreviated by A, which means amps. Okay, amps. A means amps. Amps or ampere. Amperes or amps for short. Amps. A-M-P-S. Amps or amperes. And then R means resistance. Okay? Resistance, which is measured in ohms. This symbol is Greek, which means ohms. Okay, let's look at a practical question. For example, in the exam, they can give you a practical question. Can be okay. on something a bit different from what you have already done. So they can give you a question like this. Okay, actually this one is too easy. Let me bring something a little bit complicated. I'll bring a thing here, which this one that usually doesn't miss in your exam. So I'm going direct to the things that don't miss in the exam. Okay, this one usually they like bring it in the exam. So this one they can say 1 ohm. This one they can say 2 ohm. This one they can say 3 ohm. Okay, and then there on top there's a battery. Okay, so I put a battery there, and then I'll put this battery at 12 volts. Okay, and then first question is calculate the effective resistance. First one is calculate the effective resistance. Okay, when they say calculate the effective resistance, they mean total resistance. I told you what effective means. So how do you calculate? The first thing is you look at your circuit. Your circuit has got those in series and those in parallel. So have you seen these two? These two, this one, these two here, they are in parallel. These are in parallel. Okay? And then this one alone is in what? Series. So it means you first solve the ones in parallel and then you add it to the one in series. Okay? Have you understood? This is in series and then that one is in parallel. Have you understood? So that's how you solve it. So I'm going to remove these. We said these two are in series. Don't get caught. I've already said this is in series, this is in parallel. So I'll start with these ones in series. So I'm removing that so that I can clear, so that I remove those. Okay, so that I have enough space. So I'm removing these. Okay, I just want to make you understand. So I'm removing those. Okay, okay, those in series, these ones in parallel. Okay, so we said this is in series and these two are in parallel. So we'll start with parallel first. You find the resistance in parallel. So we say parallel first. Okay, parallel resistance. Okay, so how many resistors are in parallel? We start 1 over RT. How many are in parallel? There are 2. I said this one and this one, they're in parallel. You remember? So there are 2. 1 over R1 plus 1 over R2. So we say 1 over RT is equal to 1 over R1 is 2. As you can see, R1 there. This one is R1. R1, this one is R2. This one will be R3. Okay? So 1 over R1 is 2 plus 1 over 3. So we'll have that. So 1 over RT is equal to 1 over 2 plus 1 over 3. Okay, so 1 over RT is equal to common denominator 6. 2 into 6, 3. 3 times 1, 3 plus 3 into 6, 2. 2 times 1, 2. Then that will be 1 over RT is equal to 5 over 6. Then you cross multiply. I think I've already told you this. So it will be 5 RT is equal to 6. You remember how we are multiplying, huh? So over 5 over 5. RT is equal to 1.2 ohms. Okay? So this one, it's for series. Okay? This is resistance in what? Resistance in parallel, I mean. That's why we're doing 1 over. So that's resistance in parallel. And then we also have resistance in series. And which one was in series? If you remember, the one that was in series in the diagram, it is this one. It was in series. These two were in parallel. You remember? So the one in series, I'll put it there. For series, the one in series, the one in series is what? It is 1 ohm. Only one was in series. So the total resistance now, total resistance is equal to series, the resistance in series plus the resistance in, total resistance is equal to what? Resistance in series plus resistance in parallel. Total resistance is equal to resistance in series plus resistance in parallel. You are adding the two, you remember? So we are going to have those resistance. So total resistance, which is RT, okay, total resistance, okay, abbreviated by RT. Total resistance or effective resistance is equal to resistance in series plus resistance in parallel. So is equal to, what's the resistance in series? From the diagram, you remember the resistance in series. You remember this one was the resistance in series, huh? You remember this one was the resistance in series. These two were in parallel, and I calculated for these two. So for resistance in series is 1. Is this one? 1. If it was 2, we put 2. If it was 5, put 5. So so resistance in series, it is 1 plus resistance in parallel. We calculated it. You remember the resistance in parallel? This one. Resistance in parallel is 1.2. So we're adding those two. 1 plus 1.2, which is equal to 2.2 ohms. That's how you do it. You see? And then the third question is, the second question now. You saw there we calculated the resistance in parallel. I mean the effective resistance. We first calculated the resistance in series, and then we later calculated the resistance in parallel. And then after we calculated the resistance in series and also the resistance in parallel, we added them, because total resistance, according to the diagram, there were two in parallel, and then one was in series. So we add the two answers that we get, resistance plus parallel, which will give you total resistance or effective resistance. So now, what is the current in the circuit? Okay, what is the current in the circuit? Okay, if they say what's the current in the circuit, they mean the whole current. What's the current in the circuit? Okay, so when they ask you about current, you come to your formula there. Resistance is equal to voltage over current. So current is equal to voltage. Current is equal to voltage on top over resistance. So current is equal to voltage over resistance. Okay, current is equal to voltage over resistance. So current is equal to, what is the voltage? The voltage is already given in the circuit. Okay, the voltage is already given in the circuit. Where was that actual question? Here. This was the one that we're looking, not this one, the actual diagram. This one, not this one, sorry. This one, this is the diagram that we're looking at. Okay, and the voltage here I've put, I'll put 12 to make you understand. 12 volts. Okay, I've put 12 volts. So just to help you to understand, so we'll say, we're going to say current is equal to voltage, which is 12, over resistance. Resistance, since they said they calculate the resistance in the circuit, So it means you need to use the total resistance, all of it, the total one, the one we calculated, this one, because they said the current, the resistance in the circuit, so meaning you use this one. Okay, you use 2.2 because this is for the whole circuit and they want the current for the circuit, so it over 2 over 2. So 12 divided by 2 over 2, 12 divided by 2 over 2, so 12 divided by 2 over 2, which will give me 5.4. Okay, 5.4, 5.4. Okay, 5.4 amps. So this is the current in the circuit. So when you're calculating the current in the circuit, you use the voltage for the whole circuit and you use the total resistance for the whole circuit. You see, this resistance is for both series and parallel. You remember it? Series and parallel. Same with this voltage is for the entire circuit. Okay. So we are continuing with the same question. That same diagram, we're not changing the same diagram. So we are now calculating see, easy. Calculate the current in the calculate the current in the you calculate the current in the let me look at the diagram again. The diagram which has got 3. Okay, so first is calculate the current in the 2 ohm resistor, this one that is here. Current in the 2 ohm resistor and also current in the 3 ohm resistor. Okay, this 2 ohm here and the 3 ohm there. Okay, so calculate current in the 2 ohm resistor here and also in the 3 ohm resistor. That's the question. The current that is passing through those. We are calculating the current in the whole circuit. Okay, we calculate the current in the whole circuit, but now we are specific. Current in the 2 ohm and also current in the 3 ohm. Okay, so how do you do it? So calculate the current in the 2 ohm resistor and also the current in the 3 ohm resistor. So whenever they are specific, if they ask you current in the resistors in parallel, you see these resistors, they are in parallel. Okay, whenever they ask you about the resistors in parallel, either this one or any that is in parallel, whenever they ask you about these resistors, the first thing that you do, you draw this box. I'll show you so that you understand. Okay, since we're calculating that current, the first thing we are now to find the current in the 2 ohm resistor. Okay, 2 ohm resistor. Okay, that's the one you're starting with. So we're calculating the current in there, in the 2 ohm resistor. The first thing is you pick that diagram. You just pick the part that has got those resistors. You pick it. It's this part. Okay, one is 2 ohm resistor here. Here's one is 3 ohm resistor. You pick this part, and then what you do is okay, for me to make you understand, first you draw your entire diagram. How is it written? It was written like this. Okay, so it had a resistor here and then it had 2 resistors this side. Okay, that's how it was written, and then it came like this and like this. So the first thing you do, okay, it came like that. Okay, and then there was a battery there. The first thing you do, you draw something like this, and then you put these. You put this car one like this, and then you put this car one like this. So what you do is you name these voltages as voltage 1 and then this one as voltage 2. So you name this one as V1, voltage 1, and then this one will be voltage 2. So voltage 2 is for the 2 ohm resistor and the 3 ohm resistor. Voltage 1 is for the first resistor. Okay, according to the diagram, what was the first resistor? Where's that diagram? This one. The first resistor was what? 1. So it means 1. The first resistor is 1. So the first resistor is 1. Where is that calculation? The one we're doing right now. I've lost the calculation. Let me see. Just wait a minute. We look at that calculation. Which calculation were we doing? Those resistance. We've been through it. Okay, wait first. See this one, no. This one, no. That one, no. I've already done this one. No. Not this one. Not that one. Not this one. Not that one. Not this one. Not that one. Not that one. Not that one. Not this one. It's this one. So again, the current in the 2 ohm. We're continuing, The 2 ohm. I was failing to find it since I've done a lot of pages. So the current in the 2 ohm. We said we draw something like this, and then we name V1 and V2. Whenever they ask you any of the current in those two which are in series, in parallel, sorry, then you split the diagram like this. You show V1 and V2. So the first thing you do, you find the current that entered in the first resistor, this one. You find the current that entered in here, the current, which is I. Okay? Find the what? The current that entered. Know the current that entered. It will help you to find this voltage here. Okay? Since we're trying to find V1, so you have to know the current that entered into this resistor. That current is the one that entered into the current for the whole circuit, the one that is entering into this circuit. You remember the current that we calculated, the 2.2. The current for the whole circuit. Where is the current for the whole circuit? The current for the whole circuit is where? Current for the whole circuit. We calculated it, guys. We calculated it. You remember the current for the whole circuit? We did it. This is resistance. Current. This is resistance for the whole circuit. But current, you see, current for the whole circuit is here. Have you seen? It was voltage over resistance. We calculated it. This one. This is the current for the whole circuit. Remember? Current for the whole circuit. Okay? Which is the current for the circuit. We calculated 5.4. So, that's the one that we're going to use there. So, for us to calculate V1, we'll say V1 is equal to, from that formula, where do you know that resistance is equal to voltage over current? So meaning voltage is equal to resistance times current. So the resistance for this diagram, what's the resistance of this for V1? What's the resistance for V1? Can you see the resistance for V1? This one was 1 amp. That was the resistance for V1. It was 1 amp. I think you remember the diagram. This one is 1 amp, this one is 2 amps, this one is 3 amp. So the resistance for the first one is 1 amp. So it will be 1 amp, or 1 in short, 1 times current that was entering it. It is 5.4. The resistance for the current for the whole circuit, 5.4, which will give me 5.4 volts. Okay? And then whenever you're trying to find voltage 2, just subtract this 5.4 from the total voltage. Remember the total voltage in the circuit. The total voltage is where? The total voltage in the circuit, in the diagram. Total voltage in the diagram, the total voltage is this one, which is 12. Okay, 12 volts. That's the total voltage. This one, 12 volts. So for you to find, since we have already found this one, V1 I mean, so for you to find V2, this one, for you to find this one, V2, this one, you're supposed to subtract the answer that you got. Okay, so for you to find V2, how are you going to do it? We calculated V1. Where is the calculation for V1? Don't want to lose my calculation. It's this one. So V1 is this one. So V2 will be equal to 12 minus V1, which is 4 minus 5.4. So 12 minus 5.4. What answer do you get? I know this calculation is a bit tense, but you need to know how to do it because it comes in the exam. If you follow it properly, you understand that it's not even hard to do. So 12 divided by 5.4, it is 6.6 volts. Remember what I said? When you calculate V1, which is this one, to calculate V2, you subtract 12 minus 5.4. That's V2. That's how we do it. V1, when you calculate it, to get V2, you subtract from the total voltage that's given. Okay? That's how you do that. And then since you have calculated these voltages now, the question was saying find the current in the 2 ohm. We're continuing, I haven't ended. The question was current in the 2 ohm. Okay? So since now you know the voltage in the 2 ohm, what voltage is in the 2 ohm? You already know the voltage is 6.6. This one is the one that is in the 2 ohm. So the voltage, so the thing is like this. There is a resistor there and another resistor here and another resistor here. So here the voltage is 6.6 for these two, and then here the voltage is here V1. This is V2. Right, this is V2. This is V1. V1 it is 5.4, and then here it's 2 ohm. This is 3 ohm. So now to calculate the voltage, the current, you use now this resistance. Now this is the one that you're going to use for these two. Since these two, they have this resistance, not 5.4, but this one for the series one. So you say current resistance is equal to voltage over current. So it means current in the 2 ohm is equal to resistance over voltage. We're calculating the current in the 2 ohm. This is the current in the 2 ohm. Remember, that's what we're continuing the same current in the 2 ohm. So what is the resistance? Resistance is 2 ohm resistor. You see, the 2 ohm resistor over the voltage for the 2 ohm resistor is what? The voltage for the 2 ohm resistor is this one, 6.6. Okay. So voltage is 6.6 is equal to 2 divided by 6.6. 2 divided by 6.6. 2 divided by 6.6, which is 0.303 amps. Okay. And then we're done now. Now I use also current in the what? In the 3 ohm resistor. Remember there are two questions. In the 3 ohm resistor, the same thing happens. Okay? Resistance is equal to voltage over current. So current is equal to voltage over resistance. What is the voltage for the 3 ohm? According to the diagram, the 3 ohm is this one. Have you seen? And then the voltage we're dealing with is this one, 6.6. So we're going to calculate the voltage. So voltage is 6.6, and then resistance it is 3. Okay, it is 3. So that is going to give us 6.6. The current is equal to voltage. Oh, I think we made a mistake on this one. Current is equal to voltage over, no, this formula we made a mistake here. The voltage is on top, voltage over resistance. So it means the resistance, the voltage is the 6 is on top here. Okay, the resistance, which is 2, this one is down, not the other way around. We swapped the formula. So meaning it is 3.3 for this one. Okay, I've gone back to the 2 ohm because the current is voltage over resistance. The voltage is 6.6. The current is 2. Okay, let's proceed on this one. Voltage, current in the 2 ohm, voltage in the 2 ohm, it is 6.6. Current, resistance in the 2 ohm, it is 3, which is equal to 2.2 amps. 6.6 divided by 3 is 2.2 amps. That's how you do it. You saw the way we do it, huh? You saw the way you did it. Make sure you're following those steps. Please try to follow it slowly so that you understand each step the way it's going. Then you will know how to do it. Because this question doesn't miss in the exam, so try to practice until you understand it.